So hello everyone, in today's video we are going to talk about DMA transfer and specifically memory to memory transfer in DMA. So in DMA there is one mode called memory to memory mode that you can use. So I'm not going to discuss about the theory of memory to memory mode, but in brief I can say memory to memory transfer is basically when you're trying to transfer some data from one memory location to other memory location. So this data transfer is basically within your memory, within your RAM. So without wasting any time, let's go to our program. So this is where we are going to write our program. Here in this case, I'm using STM32 F1 board, specifically the F103 blue pill board, but the process for using DMA will be same, almost same across all the boards. So in order to use DMA, first of all, you have to enable the DMA. For that, you have to go to your RCC section. And in my case, my DMA is connected to AHB bus. And since in the blue pill board, STM32 F1 board, we have two DMAs, you can enable any one. So I'm going to use DMA 1 in our case. So I'm going to enable DMA 1. Let's start writing our program. Next, you can go to the registers of DMA. And we have to do configuration in the DMA channel configuration register, or DMA CCR for short. So the first thing that we have to do in order to use memory to memory mode, we have to enable this this bit, that is memory to memory bit. Okay, this is bit 14th, so I'll enable bit 14th. And here you have to specify what channel you are going to use. And if you don't know about channel, you can read the reference manual. You can go to DMA section. You can figure out how many channel does your DMA have. Okay, in this case, blue pill board has two DMAs, and in one DMA you have 7 channels, and in the other one you have 5 channels. So total 12 channels I have in my case. So I'm going to use channel 1. So I'll be using CCR of DMA channel 1, and I have to enable bit 14th for memory to memory transfer. I'll be writing comments so that it is easier for you to follow. Next thing what you have to do is the next bit is priority level bit. Okay, it's not necessary to set. By default it will be low priority level. If you want to change the priority of your DMA transfer, then you can change it, but in my case I'm going to leave it. Next is the memory size. Memory size and peripheral size is basically the size of data that you're going to transfer. Okay, so one of this will work as your source address and the other one will be your destination address. Now what will be your source address and what will be your destination address will depend upon this direction bit. Okay, so if this direction bit is set as 0, it says read from peripheral, which means your peripheral will be source address and your memory will be destination address. And if you set it as 1, it says read from memory. It means your memory address will be your source address and your peripheral address will be your destination address. Okay, so in my case I'm going to leave this direction bit in default condition, that is 0. It means peripheral will be my source address. And since I want to transfer 16-bit data, you can transfer any amount of any size of data that you want to transfer. It can be 8 bits, 16 bits, 32 bits, but just for the example I'm going to take 16-bit data. Okay, so I have to set 10th bit as 1, and similarly for peripheral side I have to set 8th bit as 1. So I'll do this over here. So it was 10th bit and 8th bit. Okay, next is your memory increment mode and peripheral increment mode. So if you are transferring, let's say arrays of data, then in that case you have to set these memory increment and peripheral increment mode. I'll show this later, but for now we'll leave it since we are going to transfer only a single variable data. Okay. Then there is circular mode. Circular mode is basically when you enable this, it will regularly do this transfer again and again. Okay. If you don't enable this, then your DMA will do this transfer once and it will stop. Okay. Next is your data transfer direction. I've already told about this. And then there are 3 bits that you can use to enable your interrupt. I'm not going to use any interrupt. And at last you have to just enable the channel. Okay, so I'm not going to set this bit since it is in default condition 0. Okay, and the reset value of this register is 000. So if you want, you can explicitly set this or reset this bit, but in my case I'm not going to do it. I'll just enable the circular mode since I want the transfer to happen again and again. And as I said, at last we have to enable the channel. Now, one thing before enabling the channel, you have to set some registers that is not inside this CCR. So those registers are basically your NDTR register and memory and peripheral address register. So first I'll set the NDTR register. This NDTR register basically tells the amount of data that you want to transfer. Okay. So in my case, since I want to transfer data from single variable to another variable, that will be only one data that I want to transfer. Let's say if you want to transfer arrays of data, then you have to input the size of the array that you want to transfer. Okay. So in my case, it will be 1 since I want to transfer only a single data. So in my NDTR, I'll just write 1. Okay. Next is you have to give the address of your source and the destination from where you want to transfer data and from to where you want to transfer data. So in my case, peripheral address is basically my source address. So before transferring data, I have to create some variables just for the demonstration. And I want to transfer 16-bit data. So I'm creating 16-bit variable and I'll call it tx data and rx data. So in tx data, I'll store some variable and rx data will be, I'll keep it as 0 so that when the transfer occurs, we can see this data, whatever is in the tx data should transfer to the rx data. Okay. Next, I'll have to create some pointers. Now this pointer I'm creating to store the address of these variable tx data and rx data. Now we can assign this pointer inside our peripheral address and memory address register. So this will be basically my destination address. Sorry, this will be source address. And here I have to typecast it because this register, peripheral address register, is a 32-bit register. And same thing I have to do for my destination address. Okay, now I think we are done with the program. Now we can check this in the debug mode. So here you see in the debug mode, I've already added these variables tx data and rx data to my watch window. So in the tx data, you can see the data that I had assigned is there in the hex form. So this is the data that I've assigned here, and the rx data is right now 0. Okay. Now when I run this, you'll see the data gets transferred to the rx data automatically. Okay. And since I've enabled the circular bit, this is going to happen continuously, which means if I assign some new value here, let's say I assign anything else, then it will be transferred to rx data immediately. Okay. Now same thing you can do with arrays. So to transfer an array of value, first we'll declare an array. I'll take the length of array to be 3. And now we don't need this statement over here. You can directly give the name of the array. And then you have to change the NDTR value because now the amount of data that you want to transfer is basically the length of this array. And now in the configuration register, you have to do one more thing, that is you have to increment your memory and your peripheral. So basically you have to enable these two bits, mink and pink bit, memory increment and peripheral increment bit. So 6th and 7th bit I have to enable. So this bit is basically what allows your DMA to go to the next location of the array, since this array will have 3 locations. Okay, so after reading the first value, the 0th index of this TX data, it will go to the first index and second index. Okay, and similarly, when the DMA is storing the values, it will do the same thing for RX data. Okay. Okay, now we can check this. So this is our array. Now when I run this, and let's say I put some value over here, you'll see it gets transferred to the RX data array. And this will happen for all the elements in the array. Okay. So whatever I put in the TX data array will be transferred to the same index value in the RX data. So this is it in DMA memory to memory transfer. I hope you liked it. Thanks for your time.